Hello. So I wanted to help with this question. Looks like they're giving us a function, f of x equals 16 minus x squared. They're also giving us a closed interval from 0 to 4. They've requested us to approximate the area under the curve using 4 rectangles. So my n is equal to 4. And then they want me to find the left endpoint using 4 rectangles and the right endpoint estimation for using 4 rectangles. So the first thing we want to do is make a table, find some points, and then plot the graph. Okay, graphs really help. So you'll see I have my table on the left-hand side. If I plug in 0 first, 0 squared is just 0. 16 minus 0 is 16. Plug in 1. So 1 squared is 1. 16 minus 1 is 15. Plug in 2. 2 squared is 4. 16 minus 4 is 12. Plug in 3. 3 squared is 9. 16 minus 9 is 7. Plug in 4. 4 squared is 16. 16 minus 16 is 0. So now that we have our points, we can start graphing the function. And it's going to be the same graph on the left endpoint and on the right endpoint, but the rectangles will be in a different position. Now you should notice that my y scale is 2s, my x scale is 1s, so be a little careful there. So at 0, I have a point at 16, and then I go right 1 up 15, so somewhere like right there. And then at 2, I have 12, so it'd be right about here. And then at 3, I have 7, so 2, 4, 6, 7 would be right about here. And then at 4, I would get 0. And I know 16 minus x squared is a parabola that's kind of opening downward, so it probably looks something like this. You should notice it's kind of scaled widely, but I like doing that so I can show the rectangles really nicely. So there's my graph. Now let's draw our rectangles. For the left endpoint, that means we start on the left side of our graph. So I would have to go over as the height, and then go straight down, and that would be my first rectangle. Repeat that process for every single point. So go right, and then down. Do it again, so right, and then down again. And then one more, right, and then down. So now you can see the rectangles, and you can see the rectangles lie over the curve, so this is going to be an overestimation. To find the area of these rectangles, it quite literally is just the area of a rectangle, right? You can actually see it in the graph. If I'm finding the left endpoint estimation, the width of my first rectangle is 1. The height of it is 16. Plus, the width of my next rectangle is still 1. The height of it was 15. Plus, and then the width of the next one is still 1, but the height of that one was 12. Right? So you see I'm doing base times height to find the area of each individual rectangle. Do it again for the last one. So plus, the width of that one is still 1, but the height of that final rectangle was 7. So you'll notice I'm not really using the final point for 0. And that's pretty common with left endpoints, is you start with the left, so you never really end up using the right one. Now it's just a matter of plugging all this into our calculator or doing it by hand. So you're really doing 16 plus 15 plus 12 plus 7, and I get 50. So that would be the left endpoint estimation, and it would be an overestimation. Do it one more time for the curve on the right. So that would be R4. But this time you would be starting on the right-hand side. So to save some time, I'm not going to graph it, but I challenge you to do that. It should look exactly the same. But with your rectangles, start on the far right endpoint. Right? So the rectangles should appear under the curve instead of over the curve. But again, the widths are all 1. So the width of the far right one is going to be 1. The height is going to be 0. Right? And you can see that from my table. Plus, the width of the next rectangle would also be 1, but the height would be 7. Plus, the width of the next one would also be 1, but the height would be 12. Plus, and then the width of the last one would still be 1, but the height would be 15. And since I'm using a right endpoint, you'll see I'm not using the far left point. Again, pretty customary for right endpoints. You're starting on the right, so you don't end up using the far left endpoint. Once again, we can kind of plug this in our calculator, or you can do it by hand. So we would get 0 plus 7 plus 12 plus 15, and that gives me 34. So these are your 2 estimations. And again, this would be an underestimation. So I like to label these things just to kind of make them stand out. So we said that this one was a overestimation, and then this one's an underestimation.